Hi, welcome back to my class in Algebra. For today, we will complete our lesson in rationalizing denominator or numerator. In the last lesson, we started out with rationalizing a denominator or numerator that is a sum or difference of two radical expressions such as square root of x minus square root of y over square root of x plus square root of y. This is a rational expression and we can rationalize the denominator. And we said last time that to rationalize is to remove the radical sign. And here the denominator is square root of x plus square root of y. And to rationalize this denominator, we have to multiply the numerator and denominator by the conjugate of the denominator, which is square root of x minus square root of y. We can also rationalize the numerator, square root of x minus square root of y, by multiplying the numerator and denominator by the conjugate of the numerator, which is square root of x plus square root of y. And we had examples similar to this in the last lesson, where the numerator or the denominator is a sum of two radical expressions with the same index 2. We said that if the index is not specified in the radical sign and you have a square root in the radical expression, it's understood that the index is 2. Such as in square root of x, the index is 2, and in square root of y, the index is 2. For today, we will take a rational expression of this form where we want to rationalize the denominator or the numerator, but the index of the radical sign is 2 or more than 2. And to do that, we apply a very important property of radical from the nth root of a to the m. The property of radicals says that the nth root of a to the m equals a to the power m over n, where m is the original exponent of the base in the radicand a. And the denominator n is the index of the radical sign. But if m, the exponent of a, is equal to the index n of the radical sign, then a to the m over n becomes a raised to n over n. And n over n is equal to 1, and a raised to 1 is equal to a. Thus, we conclude that the nth root of a to the m, if m is equal to n, becomes the nth root of a to the n. And this simplifies to a. Which means that if you see a radical expression where the index is equal to the exponent of the base, then this radical expression simplifies to the base a. Again, if the exponent of the base is the same or equal to the index of the radical sign, the radical expression simplifies to a, the base of the radicand. Examples, the fifth root of x to the fifth power, the exponent of x5 is the same as the index of the radical sign, 5. Then the fifth root of x to the 5 is simply x. Another example, the seventh root of y raised to 7. The exponent of y, 7, is equal to the index 7. And the seventh root of y to the 7 is simply y. We take this as our first example. We want to rationalize the denominator, or we want to remove the cube root from the radical sign, the cube root from the denominator. And to do that, we multiply the numerator and denominator by a rational expression where the numerator and denominator are the same radical expression whose radical sign has index of 3. Also multiply the denominator with a radical expression whose index is 3. And we multiply this radical expression with this radical expression whose radicand is the same as the radicand of the expression we want to rationalize, except for their exponents. We multiply the numerator by the cube root of 2x, but with different exponents for 2 and x. We also multiply the denominator by the cube root of 2x. Product of 2x but with different exponents. Now we want to, when we multiply the denominator, this cube root of 2x multiplied by cube root of this product of 2x with raised to some exponents, we want the exponent of the product of 2 and 2 here raised to some exponent to be equal to the index 3. Now the exponent of 2 here is equal to the index 3 minus the original exponent of 2. If you write the exponent of 2 here, it is 1. And the exponent of 2 here will be the index 3 minus the original exponent of 2, which is 1. Hence 3 minus 1 is 2. It's the same in the numerator. The exponent of 2 will be the index 3 minus the original exponent of 2, which is 1. 3 minus 1 is 2. In the same way, we find the exponent of x by subtracting the original exponent of x1 from the index 3, or 3 minus 1, the exponent of x is 2. And it's the same with the numerator. The exponent of x is 2, or the index 3 minus the original exponent of x1. 3 minus 1 is 2. Now we simplify by multiplying the numerators and denominators. In the numerator, we have 6x multiplied by the cube root. 2 raised to 2 is 4. Multiplied by x squared. In the denominators, we multiply the cube root of 2x and cube root of 2 squared and x squared. And we apply the property of radical. This property of radical says that if you are multiplying two radicals with the same index n, this can be written as a single radical expression with index n equal to the common indices, the common index of the two radicals. And the radicand is the product of the radicands of the original radical expressions. Hence, applying this property to this, the cube root of 2x multiplied by cube root of 2 squared x squared is equal to the cube root of the product of 2x. We specify the exponents of 2 and x. Multiply by 2 squared x squared. The numerator cannot be simplified further. We cannot extract the cube root of 4 or the cube root of 2. So the numerator is a 6x multiplied by cube root of 4x squared. For the denominator, we simplify the radicand by applying property of exponent. This property of exponent says that if you are multiplying two exponential notations with a common base, copy the common base and add the exponents n plus m. Thus, a to the n multiplied by a to the n is equal to a, the common base, raised to the sum of the exponents of a, n plus m. We apply this property of exponent to simplify the radicand. We have cube root two raised to 1 multiplied by 2 squared. The common base is 2. So we add the exponents. 2 plus 1 is 3. Thus 2 raised to 1 multiplied by 2 squared is equal to 2 raised to the power 3. 1 plus 2. And we apply the same property of exponent to multiply x raised to 1 multiplied by x squared. The common base is x. And we apply this property of exponent. We add the exponents of x. 1 plus 2 here is 3. And we simplify the radicand further by using another property of exponent. This property of exponent says that the product AB raised to n is equal to A raised to n, B raised to n. Each of the factors in the product AB is raised to the same exponent n. But to simplify this radicand, we start from the right-hand side of this property of exponent. If we have A to the n, B raised to n, we can write this as the product AB raised to a single exponent n, where n is the common exponent of A and B. Hence, this cube root of 2 cube x cube can be written as the product 2x raised to the common exponent 3. Again, by property of this exponent, the radicand 2 cube multiplied by x cube is equal to the product 2x raised to the power 3. Now, we can now simplify the denominator by applying this property of radicand. The nth root of a to the n is equal to a. If the exponent of the base n is equal to the index of the radical sign n, then the nth root of a to the n is simply a. The exponent of the base 2x is 3, and it is equal to the index 3 of the radical sign. Thus, the denominator simplifies to 2x, the base. The numerator is the same, 6x multiplied by cube root of 4x squared. And we have simplified the denominator by applying this property of radical. The nth root of a to the n is a. The exponent of the base 2x is 3, and it is equal to the index 3 of the radical sign. Thus, the denominator simplifies to 2x. And you can see that 6 is divisible by 2. 6 divided by 2 is 3. And we can cancel out x because x over x is 1. And we have 6 divided by 2 is 3. Multiply by cube root. Six divided by 2 is 3. And x divided by x is cancelled because it's equal to 1. 3 multiplied by cube root of 4x squared. Thus, the given rational expression 6x over cube root of 2x, after rationalizing the denominator, simplifies to 3 multiplied by cube root of 4x squared. For our second example, consider the following rational algebraic expression. We have 8y cubed divided by the fifth root of 32 multiplied by x cubed multiplied by y squared. This is an example of rational algebraic expression because it is a ratio of two algebraic expressions. The numerator is a monomial, while the denominator is a radical expression with index of 5. Now we will rationalize the denominator. To rationalize the denominator is to remove the radical sign from the denominator. But first, and to remove the radical sign from the denominator, we must make the exponent of x equal to the index 5 of the radical sign. We also must make the exponent of y equal to 5, the index of the radical sign. And the numerical coefficient 32 we must write as a number raised to the power 5. And we know that 32 is equal to 2 raised to the power 5. Since 32 can be expressed as a number raised to the exponent 5, or 32 is equal to 2 raised to 5. And so, if we take the fifth root of 2 raised to 5, that simplifies to 2. And so we do not have a problem with 32 because we can extract the fifth root of 32. So we might as well separate the fifth root of 32 from the fifth root of x cubed multiplied by y squared by applying this property of radical. This property of radical says the nth root of the product AB is equal to the nth root of A multiplied by the nth root of B. Or you can read this from the right. If you are multiplying two radical expressions with common index, they can be written as a single radical expression with index n, the common index. And the radicand is the product of the radicands A and B. First, we write 32 as 2 to the power 5. So the given is equal to 8y cubed divided by the fifth root of 32, which we have written as 2 raised to 5, multiplied by x cubed multiplied by y squared. We now separate 2 raised to 5 from x cubed y cubed because we can extract the fifth root of 2 raised to 5. And we apply this property of radical to the denominator. Using this property of radical, we split this into two product of two radicals with the same index 5. So the fifth root of 2 raised to 5 multiplied by x cubed multiplied by y squared is equal to the fifth root of 2 raised to 5 multiplied by the fifth root of x cubed y squared. And the fifth root of 2 raised to 5 can be simplified because the exponent of 2, 5 is equal to the index of the radical sign. And we apply this property of radical the nth root of a to the n, the exponent of a is n is equal to the index n of the radical sign. And this simplifies to a. And applying this property to the fifth root of 2 raised to 5, the fifth root of 2 raised to 5 is simply 2. The numerator is 8y cubed the numerator is 8y cubed divided by the fifth root of 2 raised to 5 because the exponent 5 of 2 is the same as the index 5 of the radical sign. The fifth root of 2 raised to 5 is 2 multiplied by the fifth root of x cubed multiplied by y squared. Now 8 is divisible by 2, or 8 divided by 2 is 4 multiplied by y cubed. Divide by the fifth root of x cubed y squared. Thus, we are left with the fifth root of x cubed y squared, and this is the radical expression that we will now rationalize. To rationalize the denominator is to remove the radical sign from the denominator. And to rationalize the denominator, we multiply numerator and denominator by radical expression with the same index 5. The radical expression in the numerator and in the denominator is the same, a product of x and y raised to some exponent. The exponent of x here is the difference between the index of the radical sign and the original exponent of x, 3. 5 minus 3 is 2. Hence, the exponent of x here and here is 2. The exponent of y is the difference between the index 5 and the original exponent of y, 2. 5 minus 2 is 3. Now we multiply the numerators and the denominators. In the denominator, we apply a property of radical because the radical expressions in the denominators have the same index 5. We can write these two as a single radical expression with index 5. The numerator is the same, 4y cubed multiplied by fifth root of x squared y cubed. And this fifth root of x squared y cubed cannot be simplified further. Now we multiply the denominators because these two radical expressions have the same common index 5. They can be written as a single radical expression with index of 5, the common index. And the radical here is the product of these two radicals, the product of x cubed y squared and x squared y cubed. Again, the denominator is the product of the fifth root of x cubed y squared and fifth root of x squared y cubed. By property of radical, they can be written as a single radical expression whose index is 5, the common index. And the radicand is the product of the radicands x cubed y squared and x squared y cubed. Now, we simplify the radicand in the denominator by applying property of exponents. We multiply x cubed and x squared because they have a common base x. We copy the common base and we add the exponents of x. 3 plus 2 is 5. The numerator is the same for y squared, for y cubed multiplied by fifth root of x squared y cubed. We multiply x cubed and x squared, the common base is x. And we add the exponents of x. 3 plus 2 is 5. And we multiply y squared and y cubed. Again, by property of exponent, we copy the common base y and we add the exponents of y. 2 plus 3 is 5. Again, by property of by property of radical. By property of exponent first, the x raised to 5 multiplied by y raised to 5 can be written as the product xy raised to the common exponent 5. We write x raised to 5, y raised to 5 as xy, the product xy raised to the common exponent 5 by this property of exponent a raised to n multiplied by b raised to n is equal to the product of the bases raised to the common exponent n. The numerator is the same, 4y cubed multiplied by fifth root of x squared y cubed. We now have written the fifth root of x raised to 5, y raised to 5 as the fifth root of the product xy raised to the common index 5. Because the exponent of xy 5 is equal to the index of the radical sign 5, the fifth root of xy raised to 5 is simply equal to xy. By this property of radical, the nth root of a raised to n is a. If the exponent of a is equal to the index n. The numerator is the same for y cubed multiplied by fifth root of x squared y cubed. Now we have simplified the denominator. The fifth root of xy raised to the power 5 is simply xy. But we have y cubed in the numerator. Y cubed divided by y by property of exponent. Copy the common base y and get the difference of the exponents. Exponent of y in the numerator is 3 minus the exponent of y in the denominator is 1. Hence, y cubed divided by y is y raised to 2. And we write 4 multiplied by y squared. And this is the final answer. We have 4. Y cubed divided by y is y squared. Multiplied by the fifth root of x squared y cubed. And we still have x in the denominator. And you notice that there is no more radical sign in the denominator. Hence, the given rational expression 8y cubed divided by the fifth root of 32x cubed y squared is the same as this rational algebraic expression 4y squared multiplied by the fifth root of x squared y cubed divided by x. The only difference is we do not have the radical expression in the denominator because we have rationalized the denominator of this radical expression. For our next example, consider the following rational algebraic expression. We have the fourth root of 8p cubed multiplied by q multiplied by p squared divided by 6p qt. We want to rationalize the numerator and we want to remove the radical sign from the numerator. And we do that by multiplying numerator and denominator by the same radical expression with whose radical sign has index 4. First, you note that 8 can be written as a number raised to a power 2. Eight is equal to 2 raised to 2, and 2 is the smallest number that can be raised to some exponent such that that number is equal to 8. Now we write 8 as 2 squared for us to know whether we can extract the fourth root of 8. But the index the exponent of 2 here, base 2 is not equal to the index 4 of the radical sign. Hence, we cannot extract the root of 8 because we cannot take the fourth root of 2 raised to 2 because the exponent 2 of the base 2 is not the same as the index of the radical sign. but we rewrite the numerator by writing 8 equals 2 raised to 2. I have rewritten the numerator by writing 8 as 2 raised to 2, and I specified the exponent of q 1. So the fourth root of 8p cubed times q times p squared is equal to the fourth root of p squared p cubed q raised to 1 times p squared over 6p qt. And we now rationalize the numerator by multiplying the numerator and denominator by the same radical expression with index 4. The radicand in the numerator and in the denominator is the same, and that radicand will contain 2p qt raised to some exponent. The exponent of 2 is the difference of the index 4 and the original exponent of 2 in the given radicand. 4 minus 2 is 2. The exponent of p is the index minus the original exponent of p, 3. 4 minus 3 is 1. And the exponent of q is the difference of the index and the exponent of q in the given radicand. 4 minus 1 is 3. And the exponent of t here is the difference of the index 4 minus the original exponent of t, 2. The constant and the variables in the denominator will have the same exponents. Exponent of 2 is 2. We multiply to rationalize the numerator. We multiply numerator and denominator by the same radical expressions with whose radical sign has an index given to the equal to the index of the radical sign that we want to rationalize in the numerator. Now we multiply the numerators and denominators. In the numerator, we write the product of this radical expression and this radical expression as a single radical expression with index of 4, or whose radical sign has index 4. And we multiply the radicands. 2 squared, we multiply by 2 squared. By property of exponent, if you have a common base, you are multiplying exponential notations with common base. Copy the common base 2 and add the exponents of the common base. 2 plus 2 here is 4. We multiply p cubed by p raised to 1. Common base is p. We add the exponents of p, 3, and plus 1 is 4. We multiply q raised to 1 multiplied by q raised to 3. Common base is q. And we add the exponents of q. 1 plus 3 here is 4. Multiplied by t squared and t squared. Common base is t. And the exponent of t here is the sum of the exponents of t in the radicands. 2 here plus 2 here is 4. Over, multiply the denominators, 6p qt. Multiply by the fourth root. Raised to 2 is 4, and we cannot extract the root of 4, or we cannot extract the fourth root of 2 squared, because the exponent of the base 2 is not equal to the index. So we simply write 2 squared as 4. Multiplied by p, multiplied by q raised to 3. Multiplied by t squared. Now, by property of exponent, these factors 2 raised to 4, p raised to 4, q raised to 4, and t raised to 4 have the same exponent form. And this product can be written as the product of 2p qt raised to a single exponent 4. So we write the numerator as the fourth root of quantity 2p qt raised to the power 4. By property of exponent, we have written 2 raised to 4, p raised to 4, q raised to 4, t raised to 4 as quantity 2 times p times q times t raised to a single exponent 4. Now, the exponent of this base 4 is equal to the index 4 of the radical sign. And by this property of radical, the nth root of a raised to n is equal to a. If you have the exponent of a, n equal to the index of the radical sign, then the nth root of a to the n is simply a. Applying this property of radical to the numerator, the fourth root of quantity 2p qt raised to 4 is simply 2p qt. Divide by the denominator. Again, by this property of radical, the nth root of a raised to n is equal to a. Thus, the fourth root of quantity 2p qt raised to 4 is simply 2p qt. Divide by 6p qt, multiply by the fourth root of 4 times p times q raised to 3 times t squared. Now, you can see that 2 and 6 are divisible by 2, so we simplify 2 over 6, and that's 1 over 3. And P divided by P is 1, Q divided by Q is 1, P divided by P is 1. Or we simply cancel out PQT and PQT in the denominator. In the numerator, we have 2 divided by 2 is 1. In the denominator, we have 6 divided by 2. We divide numerator and denominator by the greatest common factor of 2 and 6 is 2. 6 divided by 2 is 3. Multiply by the fourth root of 4pq raised to 3 times p squared. Hence, we have removed the radical expression from the numerator. The fourth root of 8pq times q times p squared over 6pqt is the same as 1 over 3 times the fourth root of 4p times q raised to 3 times p squared. Except that we do not have anymore the radical expression in the numerator. For your practice, please try the following exercises. Your exercise consists of 2 parts. In part 1, letter A, rationalize the denominator. Number 1, we have 3xy over the cube root of 3x squared y. In number 2, we have 15m squared n divided by the fourth root of 81m n cubed. And for you to be able to check your answer, I give you the answers for this part of the exercise. Number 1, the answer is cube root of 9xy squared. For number 2, the answer is 5m multiplied by the fourth root of m cubed n. The second part of your exercise, you are asked to rationalize the numerator. In number 1, we have the fifth root of 3a squared b cubed over 27ab squared. In number 2, the given is the fourth root of 16p squared q squared over 2p squared q squared. Again, for you to check your answers, I give you the answers for this part of the exercise. For number 1, the answer is 1 over 9b squared times the fifth root of 81 multiplied by a cubed b squared. For number 2, the answer is 1 over pq multiplied by the fourth root of p squared q squared. Please try the exercise. If you have question about the lesson today, you ask your question in the comments below. And don't forget to subscribe to my YouTube channel, Art Kalisan, the channel of learning and pleasure. Or please ask your friends and classmates to subscribe to my YouTube channel, Art Kalisan, so they may learn as well. And thank you for joining me in my class today.